So now we will give some more illustration. Some of it is pretty usual thing as before. So copying a Python array. Okay. So I showed one way before. What was it? So C equal to A colon. This was one thing. So it will create a copy. C equal to A does not create a copy. Okay. So if I do this in Python, so I have array A with a lot of entries. But if I do this, then I'll create a new array with same entries. Okay, but there's some more other ways to do it and some subtle things. If a multi-dimensional array or multi-dimensional list, especially list, then it has to be carefully done. Okay, so let's also understand what is assignment operation. So assignment operation do not copy objects. We saw that. I just showed you that if C equal to A is C is not a new object. It is pointing to the same object. So equal to operator, it only creates a new variable that shares the reference to the original object. So this is the key. Okay, it shares a reference. So this is thing which you see, and that is why Python is a reference type, has reference type variables. Okay, so this is a repetition, but it's a good idea to repeat it often. So X is, we have numpy array 1, 2, 3. I print, so let's print it here. His ID is 184. So Y equal to X. So Y is the same thing as here 1, 2, 3, and ID of Y is same ID. Why? Because we did this before. So this is the object, and both X and Y point to the same object. Okay, so that's the idea. So when I say Y equal to X, I'm not creating a new array, but as I said, in C or C++, the array will be copied. So there's a function called asArray. Here asArray function, this one. So this renames X or convert an object to an array. Okay. So this in fact doesn't create a, so let's see. So we will look at both output as well as the code. So X is the numpy array 1, 2, 3. Y is, I write np asArray X, and I print xy and id xy. If I print it, I get same 672, 2672. This is what I get, idx, idy. So that means it is same object. asArray is pointing to the same object. So it is like before. Oh, sorry. Like before, we had object 1, 2, 3, and both X and Y point to the same object. But now I create a new, well, by the way, the same thing works for list. This is for numpy array. Now this is for list. This is 2, 3. W is asArray Z, and you can see that they are same object 3, 5. So Z was, so this is for to create an object to an array. Okay, so this second part, this I take back. So Z is 2, 3. Then W is array Z. So it is going to create a numpy array. So this W is numpy array. So it's a different object. So Z and W are different objects, though they look the same. Okay, but like numpy array and list are different. Huh? For example, if I say Z equal to 2 star Z, if it's list, well, Z is a list, so it will create 2, 3, 2, 3, like this. Okay, but if I do it for W, then I will create each element by element doubles. So the list and numpy arrays are very different. Like I cannot apply square root on a list, but I can do it on number array. Okay, anyway, so this ID of W and ID of Z are different. So 3520 and 3920. So they're different objects, so their ID will be different. Now this is a very important function called deep copy. So copy is a module. Okay, this copy is a module, and within the module we have the deep copy. There are two functions which we need to keep in mind: either copy or deep copy. Now let's think of the difference. Okay, it's a key thing, and when I'm doing this programming, I need an array. So it would be lazy thing to do is C equal to A colon. It's better to use this function deep copy. Now I will show the difference between copy and deep copy. So there's another function called just copy.copy. Copy.copy. So deep copy makes a deep copy. Okay, so what is it, deep copy? So all the objects of the structures are copied recursively. So you make a true copy. We show that this copy, if I just say copy.copy, it is not a true copy. Some objects within the structure will be shared if I do this copy. So this is a picture. I hope it is clear. I have taken from this website. So we have this object bag1 which has 4 elements. So we have this 4 names. I have Mandi, Ron, Jacob, Bike. If I do a deep copy, then I create identical copy. So this is a bag2 with these objects, 4 objects. Well, this object and within that there are objects. So it's identical. So this was the original one and this is the later one. So let's look at the example. Well, so on contrast, copy.copy makes a shallow copy. So deep shallow. Okay. So shallow is a contrast. Shallow copy creates a new compound object and constructs a new collection of objects and then populates with the reference to the child objects found in the original. So it is going to reference. So that means shared. So some of the objects will be shared. Let's look at it here. So this was the original, in fact all of it. So let's put it here. This is my original object. Okay, so I can use the red color. So this is my original object. I make a copy. So my copy is here, this one. So I may think that okay, it has made a copy, but no. These objects, some of these objects, median, Ron, it is not copied. So both bag1 and bag2 are pointing to the same object. So this object is common. Okay, so well, I mean, we don't get a independent copy or full copy with copy. So if I say deep copy, then we get a true copy. Okay, and this is slightly dangerous. I mean, I'm doing something, I made a copy and I think that I'm operating on the objects in the copy, but we are not. We are operating also on the original array. Okay, so that can create some confusion. So some example, if I'm just doing copy, so this is import copy. Okay, so you have to import copy. So I have array X, which is a 2D array, 1, 2, 3, 4, right? I mean, you can think of 1, 2, 3, 4. So 1, 2, 3, 4. Okay, so it's a 2D array. Now I make a copy. So y equal to copy. So this was X. Now y is supposed to be copy. It turns out it works well here. So just one second. Huh? So y made a copy. So if I make a copy, then it will be copied. Now I make a change in y. So y00 has become 100. So what happens to x? X is as before because I changed y but not x. So since it is copied, so I get this 00 entry is 100 and other objects remain the same. And you can look at the ID, they are different IDs. So this is 944 and this 016. Okay, so this works great. 2D arrays is fine. But now let's look at slightly more complicated object. X is 1, 2, 3, 5, 4. And it has how many elements? It's a list. So the list is 1, 2. This is object which is 3, 5 and 4. So it has 4 objects. Okay, 4. And one of them is compound object, which is a list by itself. So there are 5 numbers but only 4 objects. So make a copy. Now I change y0, which is this y0 will be 1. 1 has been made 100. And y20, 20 will be 0, 1, 2, so 2 and 0. So second level of index redirection, so 3. So 3 has been replaced by 200. So this is what I'm doing here. So this is to be replaced by 200 and this to be replaced by 100. Now I like to see whether this indeed happens or not. So we're going to print both x and y. Okay, here print x and y. So let's see what we get. So x is 1, 2. Well, since y is a copy of x, if I'm changing y, it should not affect x, right? So, but this 200 is affected. Well, the 3 has been replaced by 200 even in x. 5 remains unchanged, 4 remains unchanged. So this 200, this one is affected in both x and y, though I made a copy. And of course we expect, well, this 1 is not changed and y0 is 100, so this is fine. But this is a worry, right? Because I made some changes in y and I'm getting it in x. And why did it happen? Because this object 200, this object, in fact 3, 5 is shared. So we have x and we have y. Some entries are different, but some entries are common. It is pointed from both left and right. So this 3, 5 is a compound object and that is common. That's what I was drawing the picture here. Compound objects are shared. In some sense, we don't want to make many copies of compound object, but it followed the convention, but it's a non-intuitive. Nobody would think that I'm making a change in y, but y is exchanging. So I think that's a dangerous thing. But it happens with copy. So if you do deep copy, the left example is same as before, so I will not discuss that. So if I change, so I make a deep copy. So you see import copy, and within copy there is a function for deep copy. After that I change y00, which is this entry 1. It has been made 100. So you see x is unchanged but y is changed with one of the entries. What happens here if I make a deep copy? So the question is, of course, in y this 1 will be replaced by 100, but what about this object 3? In y of course 200, but what about x? So let's look at x. So in y there are two entries are changed compared to x. So this 100 and 200. However, all the entries of x are unchanged there as before, and this is because of deep copy. So deep copy made sure that we have x and y are totally independently copied. Okay. So so here I am making a copy, but sometimes we don't want to make a copy, right? I give the example. I was saying x equal to x plus 2 plus 2. In C I was expecting that, well, I was expecting not C. C doesn't allow this kind of thing. In Blitz is allowed. Blitz is allowed, and Fortran 90 also is allowed. If I do this, I expect element to element every entry is getting incremented by 2. Okay, but in Python, no. I create a new array X. Okay, so there are two different arrays. So this array X is new array, and this array X is old array. Unexpected. Okay, so we showed this example X star 2, but if I want the same array, then I should just multiply this differently, star equal to X. So this will create a new array, right? You can see the ID, there's different IDs, 208 and 080. But if I make it plus equal to 2, then my ID is unchanged. So it is going beyond my picture. So here ID of X is the same in both the stuff. So you're not creating a new thing. So this is an interesting example. What if I want to do X to the power 4? How do I do it? So if I say X equal to, well, if I do X star 4, I create a new array X, which is not good. So what do I do? So I say, well, X equal to, so like this. So I wrote X equal to X star, star X. So this is X cube. This is X cube. So I am multiplying X with itself and X cube. So here the address doesn't change. So this is a nice way to do it. So I'm using power function, but one less, and I'm using star function. Okay, so this is some number computed. I believe, I don't know, I mean, it's probably temp variable, and then multiply. So X is same array. So in C++, integer float variables are variables by value. Okay, so they're value type variables. But in C++, the objects. So you think objects, there could be reference or variable by reference. Okay, so this, I'm sorry, this is this is error. So this should have been value, variable by value, depending on the function call. So let's look at it. So here, so we didn't focus too much on C++. Well, in fact, we did not much programming with C++ or C, but this is for completeness. So we have a function y test. So it takes an argument, and argument is an object. Okay, we can pass an object. That's the beauty of C++. We can pass an object. So what is the ampersand doing? This is by reference. So inside the function, this object is not copied. By the way, copying objects are expensive. So I may have a big object with maybe 10,000 entries, and so copy should be avoided. So this is by reference. This is by reference, and test my object. So I just call like that. So here there is no copying, so it is by reference. Okay. However, if I just say type arg, this one, so here there is no ampersand, then I'll make a copy. So the whole thing is, I'm sorry, there's a error here. So my object, there should be underscore here. Okay, there should be underscore, one variable. So test my object. So this is, I first create an object of type, and then I call this function. When I call it, it's going to be copied. So arg will be a copy of my object. So if I do something inside the function, it is not going to affect my object. Okay, this is standard. So instead of array or integer, you are thinking of objects. There's one more thing. What if I put a star? So this is by reference, because star is indirection. So R is a pointer. So these two are same. So this is variable by reference. These are two by reference. Variable by reference, and these by value. Okay. Oh, this copy. So Okay, so in summary, so Python arrays are and variables behave differently than C. Not everything is different, but there are some very subtle differences, and we need to be careful. So, for example, C++, this is 2-star is update variable is same as before, but not in Python. Also, we need to be careful in. So we should avoid creating unnecessary Python arrays. Why so? Because each array, well, small arrays are fine. Well, it's not fine, but it's not critical. But in GPUs, well, memory is very limited. There could be 40 GB of RAM, and each array could be 1 GB array, or it could be 5 GB array. And you make a copy. First is waste of time, because each copying will take time. Second, you are losing this precious memory, which is only 40 GB or 60 GB. So we do not want to create new arrays. Okay, and these are the two things we should keep in mind. When new arrays are being created, we should avoid them. Or when you want to create new arrays, then you should create new arrays. You should not be so creating arrays, we should know that this new array is being created, or avoid the arrays, then you should know that our array is being avoided. So for integer, float, it doesn't really matter. It's not so critical, but for things like large arrays, it matters. Okay, so thank you, and I hope you enjoyed this discussion.